Okay, we started. Good. So what we're trying to do is problem number 54 of the triangles. And the problem is that I have a equilateral triangle and I've got an inscribed circle. And that's an awful picture, I guess. And what we're doing is then we inscribe another circle and then another circle, and we do that at each of these corners. And the question is how much, and we keep going. It keeps going in and in, smaller, smaller, smaller. And the question is what is the area of all the circles? And we are in a series situation, so we're assuming we can write this as a series. So I'm going to give you 2 hints, and we're going to see if you can figure it out from those 2 hints, okay? Maybe it's more than 2 hints, I don't know. So let's go back to our equilateral triangle, and let's put a circle here, okay? Now, what's the side of this triangle?
1.
1, okay. So if I put the center here, that should go up a little more. If I put the center there, let's see if I can erase that. I can't, it's driving me crazy. If I do that, what does it do? Yeah, that's awful. I should be able to get rid of that easier. Yuck, 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 yuck. Wow, why is it so hard to erase? I don't know. That's okay, fine. Okay, so what I want to do is ask the question of what is the radius of the circle, because I need to know that. So the side is 1. I need to know what the radius of that circle is. Well, here's something I'm going to tell you. My claim 1 is that anytime you have an equilateral triangle, the radius of the circle is 1/3 the height. And I'm going to prove that to you, okay? So I am saying the radius of this circle is 1/3 the height of the equilateral triangle. And in this case, what is the height of this equilateral triangle? Do you know?
You have to do Pythagorean.
Well, actually, I'm going to call this side S instead of 1 so that this works for general problems, okay? So the side is S. What is the height then? Well, this is what angle is that? Do you know for an equilateral triangle?
45.
No.
60.
60. Yeah, because it's 60, 60, 60 is 180, right? So what's this angle?
That's 30.
That's right, 30. That's right. And that's a right triangle right there. So 60-30 triangle, do you remember how that worked? Well, the side opposite, the 30, is the smallest one. And then the hypotenuse is twice that. So this is 2 times S over 2. And then the side opposite 60 is the square root of 3 times this. So this will be the square root of 3 times S over 2. So the height of this equilateral triangle is square root of 3 over 2S. Okay? Now, I want to prove that this right here, well, that's R, because it goes to that point right there. This is R. I want to prove that little bit right there is also R. How can I do that? Well, if I draw the radius that is to the tangent line, to where this thing touches is tangent to the circle, that angle right there is a right angle. Does that make sense? Mm-hmm. If that's a right angle and that's 30, then what's that angle there? What's
60.
that? That's right. We got another 60-30 triangle, right?
Yeah.
Okay. So in this problem, the short side is R, right? And what is this right here? Well, that's 2R.
Yeah.
No. This is 2R, sorry. This is 2R. This side right here is 2R. Ooh, see? If that's R, then the side opposite the right triangle, the hypotenuse, is twice that, and then this is the square root of 3 times that, times R. So this is actually the square root of 3 times R. Okay? So look what we get right off the bat. That's R. This whole thing is 2R. And if that's R, then how much is the height of this right here?
R.
R. Which means the circle goes up 2/3 of the way up. Isn't that cool? Mm-hmm. So that little piece left over, and that's going to become a big deal, is height R. And even better, we get r in something in terms of s, because what we get here is that r is the square root of 3. Square root of 3r is s over 2, and that's how we figured that out here too. So if we get, let's write this. We get, where am I? Oh, we get square root of 3r is equal to s over 2, half the side. So we get r is equal to s over 2 root 3. And here we got the height being, this whole height being root 3 over 2s. So it may, if you would look at it, you could see that actually 3 times this, the square root of 3 would divide into a 3 and give you square root of 3 on the top. So still, what we end up with, a fact that's very important, is that in this picture here, whatever this radius is, in this picture the radius is what? It's 1 over 2 root 3. And you can use that to find the area of that big circle.
Okay.
It also tells me that if I drew this tangent line right there, that's tangent to both these circles, right? This is r, this is r, and the height of this new equilateral triangle is r with a new inscribed circle. So my question is that can you see that each time we do this, we make a new triangle right there, and this triangle will have 1/3 the height of the original triangle. So this height is 1/3 this total height, and this height is 1/3 this total height. And each time that's going to be the radius of the previous one. So if you think about it, as we build down and get smaller and smaller triangles and smaller circles, the area is decreasing each time. Maybe not by 1/3, but something like that, maybe 1/9 or something like that. So see if you can figure out what this decrease pattern is. And if you can do that, then you would take the big circle plus 3 times the rest of these circles, this pattern, and you'll get an answer. So think about that and see if you can get something, and I'll come back to you.
Okay.
It's a hard problem. So you might want to pass by it and do something else. But it's staring at you. It wants to be answered.